Hi, my name is Mark Lawrence. I'm the founder of Carbon Collectible NFTs. Our goal is to add equity and inclusion to climate finance. The actual problem that we solve is that mature forests in low-income communities are actually excluded from climate finance. Traditionalists regard their carbon sequestration as business as usual and not additional. As a result, community members resort to illegal logging and starting bushfires on their own land in order to convert their forest land to farmland so they can feed their families. We've also developed a satellite navigation application which bypasses traditional carbon intermediaries who are both exclusive and unaffordable. This sat-nav app also adds provenance, transparency, and rarity to NFTs backed by our Web3 carbon offset. According to NASA, since the start of the Industrial Revolution, the amount of greenhouse gases in the atmosphere has increased exponentially. Now, greenhouse gases like carbon dioxide allows the sun's rays to penetrate on the way to the Earth's surface. When those rays are reflected from the Earth's surface, they are reflected at a higher frequency, or in fact lower frequency radiation. This radiation cannot penetrate the same carbon dioxide molecules, and so the heat is captured within the atmosphere. This causes global warming. And so the chart on the right actually shows the increase in the average surface temperature since the start of the Industrial Revolution. And according to NASA, the main causes of global warming are burning fossil fuels and cutting down carbon-absorbing forests. So I guess we should stop burning fossil fuels and we should stop deforestation. So each of us has a carbon footprint that leads to greenhouse gases being emitted into the atmosphere. And trees and forests are really good at removing carbon dioxide from the atmosphere. They use energy from the sun and water to actually convert carbon dioxide into oxygen, glucose, and carbon, which is stored in the trees and in the biomass. So what is a carbon offset? So carbon allowance is the right to emit 1 ton of carbon dioxide into the atmosphere. So in California, for example, the state of California has a cap and trade program. This means that the electricity company, for example, is only allowed to emit a certain amount of carbon dioxide into the atmosphere each year. If they exceed their cap, then they have to pay a fine. Alternatively, they can buy carbon offsets from somebody else who's removing carbon dioxide from the atmosphere or avoiding the emission of carbon dioxide into the atmosphere. So those carbon offsets are actually generated by forests, for example, who are removing carbon dioxide from the atmosphere, or wind farms who are avoiding the emission of carbon dioxide into the atmosphere. Now, if there's a cap and trade program like there is in California, in Europe, etc., then the electricity company, for example, can only buy carbon offsets from a regulated exchange. These are called compliance carbon offsets. There's also voluntary carbon offsets, where companies like Toyota and Amazon just volunteer to be carbon neutral. Anybody can buy or sell voluntary carbon offsets. The problem is that certification costs can exceed $700,000 and $1 million or more. So traditional carbon offsets, their goal is to incentivize new carbon sequestration, and this excludes mature forests from selling carbon offsets. And certification costs are really unaffordable for low-income forestry communities. Our goal is to add equity and inclusion to climate finance. So we include mature forests, and our goal is to drive down certification costs towards $0. How can we do this? We actually do this by using satellite imagery, machine learning, and artificial intelligence to calculate the carbon sequestration rate of our forests. We actually use data from a third-party oracle who actually monitors all of the forests around the globe. We also use a blockchain to eliminate double counting by tracking NFTs that map onto each hectare, each plot of forestry within our forest. And we also used a SEC FINRA certified broker dealer who verified the right of sale. So does the forest In the Volta region of Ghana, the Abatime forest, does it exist? Do the proponents have the rights to sell the carbon sequestration? You also check with the Forestry Commission, which is the government, to verify that they actually had the right of sale. And by the way, using satellite imagery, machine learning, and artificial intelligence allows us to bypass intermediaries. And because we're doing that, we can drive certification costs down to $0. Chart on the left here actually shows the boundary of our forest within the third-party Oracle's database. And so on the left-hand panel, you can see the calculation of carbon sequestration rates. And what we have done is we have subdivided our forest into 1 hectare blocks. That's about 2.5 acres. And each of those plots of forest land actually maps onto an NFT. And the NFT owns the virtual rights to that 1 hectare block of forest land, not the physical rights to the trees or the land, but the virtual rights to carbon sequestration and also for gaming and metaverse applications. On the right-hand side, you can see a table that lists all of the hectares that we have. We actually have 66,000 hectares. This is showing 7 of them. For each hectare, we have the longitude, the latitude, the number of Web3 carbon offsets that are calculated by a satellite navigation app. We also have a list of rare sites. Within our forest, we've got waterfalls and caves, a monkey sanctuary, and all sorts of rare sites. And what we do is we geolocate those rare sites and indicate whether they're close to a particular hectare of land. If so, the NFT that's associated with that hectare of land has physical rarity. And so our solution, our NFT solution, has utility because it's backed by at least 5 carbon offsets. It has provenance and transparency because we have a satellite navigation app that allows the owner of an NFT to input the serial number of the NFT. Then we use satellite navigation to zoom in on our forest and actually zoom in on the hectare of land that's associated with that NFT. And we also have physical rarity that's associated with each plot of forest land, which in turn is associated with each NFT. So this chart here shows that we have 20,000 hectares that have more than 6 carbon offsets and 35,000 hectares that have more than 5 carbon offsets. We're actually advertising 5 carbon offsets per NFT. So there will be surprise and delight when somebody buys an NFT. They expect 5 carbon offsets. They're probably going to get more than that. So in terms of rights, when somebody buys that NFT, they get digital and virtual rights, but not the physical rights to 1 hectare of mature forest. The price of an NFT is $500. That's $10 per offset per year. And there's 5 offsets per NFT and a 10-year term. And also what we do is we take 65% of the proceeds from the NFT sale and we reinvest it into the local forest community. 15% goes to the traditional council and they spend that money on forest management and other activities. 50% of that we reinvest through a social innovation studio. This is like a venture capital fund, but what we do is we ask the local entrepreneurs, what are the problems that you're facing, unemployment and other issues? What are your solutions to those problems? Then we take those problems and solutions, bring them back to our crypto community who will leverage Web3 innovations to completely reimagine sustainable and profitable solutions to those challenges. This will lead to entrepreneurship, hopefully new jobs, alternative livelihoods, and economic growth. And so, as a summary, in providing equity inclusion to climate finance, we provide enhanced utility over a traditional carbon offset. We provide additional and enhanced provenance and transparency that you do not get with a traditional carbon offset. We provide physical rarity that you do not get with a traditional carbon offset. We have a Web3 solution, and in time, our solution will evolve to a peer-to-peer marketplace where landowners will be able to stake their plots of land and buyers will be able to buy the carbon sequestration rates or carbon offsets directly from the seller. And we also have our social innovation studio. So this is actually showing that traditional carbon offsets are really a Web 1.0 solution. They have traditional historical carbon, but the information, value, and staking are all consolidated in these intermediaries, and the farmers are kind of left out of the equation. For typical Web 1.0 solutions, the farmer gets less than 1% of the value. Some people are proposing that they tokenize traditional carbon offsets. If they do that, then maybe information is no longer centralized and the information passes down to the farmer. But value and staking are still centralized within the intermediaries. In a Web 2.0 world like we have today, when you buy a cup of coffee, less than 0.5% of the price of that cup of coffee actually goes to the farmer. On the other hand, we are proposing a Web 3.0 solution. So it includes traditional historical carbon, just like traditional carbon offsets that we don't even value, because we have current carbon sequestration, because you're sponsoring, each NFT sponsors a live hectare of trees that are sequestering carbon dioxide today, tomorrow, next year, and the year after that. So current and future carbon sequestration rather than just historical carbon. We also have enhanced provenance, enhanced rarity, and gaming and metaverse rights are also conveyed with the NFT. In our case, 65% or more of the value actually goes to the farmer. This illustrates the art of our promotional NFT. So we've actually got a promotional NFT and also a paid NFT that conveys the rights to the forest land. This illustrates the paid NFT, and this NFT is actually an avatar. When you mint the NFT, you can actually select attributes for the avatar, and then those attributes are stored in your wallet, and then potentially these avatars can be used in gaming and other metaverse type applications, hopefully that have a forest type theme to them. This actually shows the seal that we will provide to organizations who want to use our carbon offsets to offset their organizational footprint. And organizations like Chainlink will eventually get involved. Today, we get all of our data from one third-party oracle. There's other organizations like NASA and others who generate similar data. And typically, organizations like Chainlink will capture data from multiple sources, multiple oracles, and then form a consensus for the industry. So today we get our carbon sequestration data from one oracle. In the future, we'll probably get our data from an organization like Chainlink, who's forming a consensus from multiple sources. This is just an indication of some of our selected team members. These are some pictures of our actual forest. And this is our contact information. At this point, we can take questions.